Hello everyone, we have a question here and it's from JAMB 1986, question 4. The question is, find the smallest number by which 252 can be multiplied to obtain a perfect square. And here are the options. Solution. Here, the question asks us to find the smallest number that can be multiplied with 252 that will yield a perfect square. Now, to solve that, this is what we do. Firstly, express 252 as a product of prime factors. Here we have 2, then we have 1, 1, 2, 6, 2 again. Here we have 6, 3. We cannot use 2 again. We move to the next prime number, which is 3. Here we have 2, 1. We can make use of, we continue with 3, 3, 7. Here we have 7, 1. Now I have expressed 252 as a product of prime factor, that is 252 is the same thing as 2 times 2 times 3 times 3 times 7. Here we have 2 raised to power 2 times 3 raised to power 2 times 7 raised to power 1. Here you see that all other factors here appear even times. 2 appear even times, 3 appear even times, 7 do not appear even times. For it to be a perfect square, each of these factors must appear even times. So here we have even times. 2 is even, 2 is even, 7 is 1. So what we need to multiply with this is 7. So that for it to be a perfect square, for it to be a perfect square, then we must have 2 raised to power 2 times 3 raised to power 2 times 7 raised to power 2. Here we are. So the smallest number to be multiplied with 252 to make it a perfect square is 7. The option is option D. Surely,